chem class, look at your spray, now back to mine, now back at yours, now back to mine.
Sadly, your spray isn't my spray. But if you stopped using a lady-scented body wash and switched to your local store's dusting spray, then you could smell like me.
Look down, back up, where are you? You're in my dining room with a dusting spray that you could smell like.
What's in your hand? Back at me. I have it. It's a formula to your dusting spray. Please.
Look again, the formula's now diamonds! Just kidding, you wish.
Anything's possible when you're spraying your dusting spray on yourself and not lady-scented body wash.
I'm on a computer. Okay, so spray cans, otherwise known as aerosol cans, are basically containers with a propellant mixture stored inside of them, typically under high pressures. In order to understand how the gas laws relate to the spray can, though, one first must realize how they work. The propellant mixture is made up of a liquefied gas, meaning that it will remain in the liquid form as long as the pressure is constant. Let's see how this works when the button is pressed down.
When the button is pushed down, the pressure within the container is reduced immediately, because there is an outlet of which to release the pressure. With less pressure within the can, the insides start to boil, making a gas layer on the top of the can. The gas layer then pushes the rest of the liquid up the tube through the nozzle. The liquid then either A. expands into a gas and becomes a superfine spray, or B. forms evaporating bubbles, eventually creating foam.
Basically, no matter what, one fluid pushes another.
Oh, yeah, that. But how does that relate to the gas laws?
Boyle's law! Boyle's law! Boyle's law! Boyle's law!
Under pressure, pushing down on me, pushing down.
There. Well, first, I'll explain Boyle's law. Firstly, Boyle's law states that volume and pressure are inversely related. What this means is basically whenever the volume of something goes up, the pressure goes down, like an elevator.
So P1 equals pressure initial pressure, and V1 equals initial volume. PF equals final pressure, and VF equals final volume. So P1 V1 equals PF VF, meaning pressure initial and initial volume equals final pressure and final volume. Okay.
Keep coming up with love, but it's so slashed and torn.
If that was to be applied to spray cans, one could see it like this. Whenever the button is pushed down, the opening releases the pressure inside. Because there is less pressure within the container, there is more volume as the gaseous layer is formed. I think. Right?
Right. Gas molecules tend to go all over the place, unlike liquids and solids. This means they take up way more room than the other forms of matter, excluding plasma. And this means that they would take up way more volume, since volume is described as how much space is taken up by a certain substance.
That's pretty sweet.
Right?
Yeah.
Because the law requires a constant. In Boyle's law, the temperature would always be the same. The pressure is always the same. Its constant would be PV. Pressure! Pushing down on me, pushing down